All right, in this video, we're going to kind of work backwards. So I've been giving you quadratic equations, and we've solved them using three different techniques: factoring, completing the square, and quadratic formula, right? But what if I gave you the two solutions and asked you to give me the equation they derived from? So if I gave you the two answers this time, could you work those backwards to figure out what equation they came from? That's what we're going to do in this example. So it says here in example number 2, to find an equation for which the given numbers are solutions. So I'm already giving you the answer. You're welcome. I want you to tell me what the equation was. So look at A with me. I have 1/2 and 1/3. So what we're really saying is that the two answers are 1/2 and 1/3. So x equals 1/2 and x equals 1/3. So imagine those are our two answers, and let's work this process backwards to figure out what equation it actually came from. So what is normally the step right before we get an answer? If we have an x equals 1/2, well, if x equals 1/2, and if we were to go backwards, then wouldn't that mean that inside my parentheses, like if this were a factoring problem, then I would have the opposite, x minus 1/2? Because when I set that x minus 1/2 equal to 0, then it gives me the opposite because I would have to add it to both sides. So I could really say that the step before x equals 1/2 and x equals 1/3 is x minus 1/2 times x minus 1/3 equal to 0, right? And if this were a bottoms up problem, because I have bottoms, I have fractions, can I actually take these bottoms and bring them up in front and say that really this is the same thing as 2x minus 1 times a 3x minus 1 equal to 0? And now that I have two binomials, I can figure out where they came from, the equation that they came from, not just its factors, by FOILing and distributing that out. I could FOIL, distribute, and combine like terms and really say that it came from the quadratic equation 6x squared minus 5x plus 1 equals 0. You should be able to work this back through and get the answers x equals 1/2 and x equals 1/3. But this is the equation that has solutions x equals 1/2 and x equals 1/3. We should be able to follow the process backwards and find the equation those answers were derived from. Kind of cool. Let's try another one. Look at B. All right, these answers look a little bit different. They have square roots in them. We have x equals negative 3 rad 2. And x equals positive 3 rad 2. Now, if those were our answers, what would the previous step look like? Well, let's follow the same process. If x equals negative 3 rad 2, then that means inside the parentheses we would have x plus 3 rad 2, right? Times an x minus 3 rad 2 equal to 0. We could FOIL this. So x times x is x squared. X times negative 3 rad 2 is negative 3 rad 2 times x. 3 rad 2 times x is just 3 rad 2 x. And then 3 rad 2 times negative 3 rad 2, remember outsides go with outsides and insides go with insides, would be negative 9 rad 4. And if you look, don't my middle terms cancel out? They have the same exact variable with opposite coefficients, so they zero each other out. I end up then with an x squared. And the square root of 4 is 2, so 2 times negative 9 is really 18, negative 18. So the equation that those solutions were derived from is x squared minus 18. If you're not sure, try it. Solve it and see if you get those answers. Set it equal to 0, add 18 to both sides. Square root both sides, because we can do that because there's just an x squared term, no x term, and I end up getting x equals plus or minus, and if I break down the square root of 18, I get 3 rad 2. X equals negative and positive 3 rad 2. So it worked, right? And so the equation that those solutions came from was the equation x squared minus 18. All right, let's do two more. Let's look at C. Ooh, C gives us 3 solutions now. So maybe this isn't a quadratic anymore. Maybe this is a cubic. We have 3 solutions, an x cubed in our graph or our function. All right, so if our solutions are x equals 0 and x equals -5 and x equals +2, what do you think the step before that looked like? Maybe something like this. X minus 2 times x plus 5 times, oh, just a lonely x, right? Or x, I guess you could say x plus 0 or x minus 0. We normally don't write the 0 in the back of things though, so we could just say x. Well then, I can FOIL, combine like terms, and then distribute the x through. When I FOILed, I got x squared minus 2x plus 5x minus 10. I combined my like terms and got an x squared plus 3x minus 10. And don't forget you have the x in the front that you need to make sure that you distribute through. And I ended up getting the equation x cubed plus 3x squared minus 10x is the equation that has those three solutions. All right, let's do one with imaginary solutions. If my solutions were x equals 3i and x equals -3i, the part right before that then might look like this, x minus 3i and x plus 3i. I could FOIL those, can't I? X times x is x squared, x times 3i is 3ix, and -3ix times x is -3ix. You notice that all of those two middle terms anyway have the same exact stuff but opposite, so they zero each other out. And then I have -3i times +3i, which is a -9i squared. Ooh, do you remember what I squared is the same as? Hopefully you remember that I squared is the same thing as -1. So I really have x squared plus 9 as my function that has the two imaginary solutions. Again, if you're not sure, try it. Take that x squared plus 9, set it equal to 0, and solve. I can subtract 9 to both sides. I can square root. I end up with a negative underneath my square root, which is an imaginary number, and the square root of 9 is 3, making sure I add my plus or minus sign as soon as I square root, and I end up getting x equals plus or minus 3i, which are the two solutions we said we're supposed to have, right? So the equation that it came from was an x squared plus 9. All right, so by now I should be able to give you any equation and you should be able to solve it using factoring, completing the square, or quadratic formula. And if I give you the answers, you should be able to work it backwards to figure out what equation it came from.